Hey everybody, welcome back to the shop. My name's Adam. So we got another weekly mix of Saturday Night Special for you, episode 172. So this week I went ahead and I finished out this hydraulic cylinder. If you missed that episode, I just published that last weekend, having to rebuild this hydraulic cylinder. This is the rod that I made for that hydraulic, and I wanted to point out a couple questions that were asked about that, and we'll do that here in just a minute. So we're going to have a whole nother episode of that coming out after SNS, so be on the lookout for that. We'll go ahead and we'll complete that project, finishing out the fab work, the welding, and then installing the seals and putting it back together. All right. So also I've got a little bit of inspection that I would like to play around with and show on this week's episode. So last week I got this really nice micrometer from Mike Rickett. This was that really nice mic, 0 to 1 inch Starrett that reads the tenths on the thimble right here. So what I wanted to do, and actually what I had done, Mike had suggested it, and something I've been wanting for a while anyway, is a nice mic holder, a mic stand. So I found this one on eBay and picked it up. Got it for a really good price. Didn't really pay a whole lot for it, so I wanted that to go along with the mics right here in the shop. So we're going to look at this new Starrett mic on that stand, and then I've got another mic that's in the shop that was given to me by another mic. So I want to go into that, and let's look at these mics with some gauge blocks and see how they read, and then do some comparison readings, especially on this other mic down here that I have that I'd like to play around with, and let's get a little bit of video capture to that. Okay, so about this hydraulic rod, there was a few questions on the past video about these scratches on here. There's several on there. There's a deep one right here, and it had a bunch of guys ask, hey, why couldn't you weld those up and then turn them back down? Well, you can do that, and that's a job that I've done a few times in, I'd say, my younger years at the old shop when I was working with Dad. There would be guys that came in our shop that worked with the local utility company or construction companies, you know, mechanics that were there to fix their equipment, rebuild it, and so forth. So sometimes they would bring in a hydraulic rod like this, and they would want it just TIG welded or welded and then turned back down. So that's what we had to do. Sometimes we had a couple of guys that would bring them in, and they would already have welded the scratches up. So you can fix it that way, and I wasn't implying in my comments that you can't fix it that way. You can. That's a great way to fix a hydraulic rod if you're in a real dire need to get that cylinder back going again, or if it's a very expensive rod to replace, you know, a lot of time and money to put into replacing it, or if you got a special size, say maybe a metric rod that you can't really find the size for right away. You know, some of the ones I remember doing were pretty big, you know, maybe upwards to about 3 to 4 inches in diameter. They had this eye was like completely casted into the rod down here, you know, so the manufacturer casted it, machined it, and chromed it, and that kind of stuff. So the problem with welding it is that your weld is not going to be as hard as this hard chrome plating on there. So where your welds are, that's going to be a soft surface right there, which could easily scratch if you get dirt on there, dirt or any kind of debris that's caught up between the surface here and the wiper as it's going up and down. So you're still gonna, you can still scratch the surface, but it'll get you by. So yes, you can do it, but for me, it's not an ideal fix. This was a 1.5 inch diameter chrome rod, something that we have in stock at work, and something that's very easy. It's very easy to get. You know, anybody can get this stuff. You order it in a day or two, and you'll have it. So to me, this is just the proper way to do it, is to replace it. Sometimes these rods have a slight bend to them because of being used, you know. They're extended out and they have a lot of force being pulled on them, so they have a little bit of a bend. So that creates a problem chucking it up in the lathe and trying to turn that little area true. But I will tell you a trick, what I did whenever I would turn the weld off is that I would just get it very, very close, use a micrometer as you're turning it, getting it very close, and then use a mill smooth file and actually filing it, because the file will slide along the chrome surface. So as you're filing it, the chrome surface is keeping the file from digging into the sides, and it's sliding across, and you can basically just hand shape that weld down to the right diameter. So keep that in mind if you ever have to do that yourself. That is one way to get it fixed. But me personally, I'd just rather replace the rod. That's just the correct way to do it. Put a new rod in it, and then put new seals in the hydraulic. So I just wanted to kind of cover that. Hope I didn't drag that out too long. So let's go ahead and get into our new our inspection that I'd like to do. So there's the new mic stand that I picked up from eBay. That's a number 206. So somebody had this on eBay and they were asking, I believe, $45 for it. I made an offer of $35 and they had 99-cent shipping on there, and they accepted my offer. So got a nice stand there for $35.99. So the way this works, and I had never messed with one of these until I got this. So this is you loosen this screw right here, and the clamp actually pivots on a ball right here. So there's a screw going through the ball and screws into the fork part of it right here that holds it, the clamp. So you position that wherever you want it. I don't know if you put your your knob on the front or the back, whatever you want, and then you snug this up, and it just pulls tight against that ball right there. There's just a simple bar. You can see that there is a screw right here, flathead, and then the knob. So the ball is right about there, and it just pulls it tight against that ball. That's all it is. Very simple design, but looks really nice. It's got the classic black wrinkle finish, and it's got a lot of heavy weight to it. It's a solid piece of steel there. So there's the Starrett 221 mounted up on the new number 206 mic stand, and that's a nice way to hold a mic whenever you've got some parts that you want to inspect. So if say you're doing a production run, you got several parts and you want to keep checking them, that's a great way to hold the mic, so you don't have to tie up one of your hands holding the mic. You can just do like that, clamp it in there, and again, you can position this however you would like. I've got it positioned like that so that the camera can see it pretty good. Let's go ahead and measure something real quick with this. We've got this is a standard. It's a 1-inch standard, but we're going to measure the diameter of it, not the length. Okay, so that's 313. Let me get it seated. So that's going to be 313 thousandths and 4/10. So I'm rotating it until it lines up with the 13 there on this horizontal line, and then I'm counting the tenths on that barrel right there. So we're at 4/10 right now. So 313 thousandths and 4/10. So this is the mic that I remember my viewer Mike Frazier had sent to me. I know it's been a little while now, but this is a different style of mic that I had never used until my viewers had sent me. I've got a couple of them now. This is the 1 to 2 inch, and I believe that they're Polish made. The very, very nice quality mic, and it reads in very fine graduations as well. The tenths read right here, so that's another reason why I want to go ahead and pull this out of the toolbox and let's talk about it. Let's see it work. So there's the box there. You've got a wrench in there to set it to 0. You've also got a standard in there. So we're going to go ahead and move this out of the way, and we'll just take a little peek at the mic right here. The very nice quality. I had it locked in. Very nice quality tool. There's the back of it. So the only markings on it are right there where it says MMCC 1 inch to 2 inch. So this would be something that you also used for inspection work. And this has a button that you push right here that disengages the barrel right here. This, you know, normally this is a fixed point, but this one moves. And what you do is you set this mic to a standard or whatever you want it to. You know, you just say a standard. You set it to a standard, and then you check your parts very quickly and accurately with a mic like this by pushing this to spread that open, and then put your part in there, and then let go of the trigger. So where'd my standard go? Oh, there it is. So we'll do that real quick. All right, we're going to run it down on there. And notice the 10th readings right there. I'm going to try not to get a glare. And I'm going to adjust that so it's right on that 0. So that is your 10th readings right there. And you see we're lined up on 0 over here. We'll go ahead and lock it. Lock it in place. So you're ready to take that out. Push the button. Pull your part out. All right, so you grab your part, you bring it back in here, you push the button. And so you can quickly check all your parts and just read this right here. You know, as long as your parts are supposed to be within, say, 1/1000 plus or minus, that'll give you a 2/1000. You know, if you're from 0, 1/1000 each direction there. It's a very cool, very interesting tool. I really like that. So let's put it in the new Starrett mic stand. And I've got a couple gauge blocks. I've got a total of 3 1-inch gauge blocks, and we got a couple of these standards also. And we'll just do some comparison readings using this mic right here, okay? All right, we got the mic set up, and in the background here I have 3 gauge blocks. We have a Micrometer, we have a Brown & Sharp, and then this is a Phase 2 brand made in China. And then we also have a couple of standards. This one's a Micrometer right here, and then this is the one that come with this mic. So let's go ahead and start with this Micrometer. Is brand new in a it was brand new in a box. All right, so this is one that I had acquired, and let's go ahead and set our mic. Let's go ahead and set our mic to that. All right, I think we're good there. Like I said, just watch this gauge right here, this needle. So that looks like it's pretty well set on 0. And I'm gonna take it out, and let's set it back in there. Okay, it looks like it's repeating pretty good. So that's going to be our setting for a standard there. All right, let's go. We'll go to the Brown & Sharp. Let me give them another wipe. I wiped them before, but looks like I handled them again. Just trying to make sure that it's squared up in there. All right, so that one, the Brown & Sharp, appears to be maybe 2 or 3 tenths under 0, and I'm talking about tenths of a tenth, so I'd be talking about millionths there. Pretty close though. All right, let's take that one out. Now let's put the phase 2 in there. All right, and the phase 2 is almost a tenth under. I'd call that probably 6 to 7 millionths under. Interesting. All right, here's our Micrometer standard right here. So that's nearly 1/10 under. That's 1/10. All right, and let's check our, this is the standard that come with this micrometer. That looks like it's over. Almost 1/10 over, not quite, probably 8, I'd call that, maybe about 8 millionths. I'm going to go back to the Micrometer and see if it's still repeating to 0, which it looks like it is. Okay, so which one's right? The Micrometer, or the Brown and Sharp, is still just slightly under the Micrometer. Not much, but it's, I mean, it's right there. And then the phase 2 is definitely smaller. All right, well, anyway, that's how that mic is used right there. You just set it up like I showed you, and then you can take your parts and just keep quickly checking them. And this Starrett mic stand would be very helpful for a job like that. So just something fun to exercise here in the shop, and I like to pull these tools out every now and then and show them all. So there you go. I hope you enjoyed that. We're going to be cutting a metric thread over here on the Acra. This is a 16 by 1.5 pitch. So what I wanted to show is a nice technique, which I have shown before, but it's always fun to revisit and show it again for the newcomers to the channel. And the reason that we're showing this is because this technique is where you actually can disengage the lead screw and line back up on a metric thread, because typically on these machines that have an American lead screw on them, or an English lead screw, you typically can't disengage because you can't line back up on a metric pitch. But this little technique allows you to do that, and it's very very cool, and that's how I do most all of my metric threading now, especially if you're coming up to a hard shoulder like that. So I'll talk you through what I'm doing. I've already got the tool touched off on 0. We've got everything. We got our compound zeroed, we got our cross slide zeroed, and I even use a dial indicator over here on the cross slide to verify my movements on the cross slide to bring the tool back to absolute 0 every time. So let's get started on it. I'm going to make a scratch pass, and I'll talk you through the process here. Okay. So before we make our scratch pass, I'm going to show you what we're doing. I'm going to go ahead and turn the lathe on. I've got it set to a 1.5 pitch. And I want you to notice this one with the yellow dot on it, letter A. That line is what we're going to use for every pass that we make. Even though we're going to disengage, we're going to line back up on that one. So before we make our scratch pass, I'm going to show you what we're going to do. So it's coming around. All right, there's our cut. I'm going to disengage, and I'm going to stop the lathe. And then what we're going to do is we're going to reverse it. And we're going to catch that same dot without it going around and losing track of it. So we'll reverse it. All right, there's our pitch. So you back the tool out, you stop the machine, and you come back into your 0. You turn the machine back on, you start making your next pass. All right, disengage it, back out, stop the machine. You know, doing this method, you ain't got to worry about crashing your tool. You just stop it like you normally would. Stop the machine, and then simply reverse. Watch that dot to come back around. All right, you're lined back up. You do that, and you'll be lined up every time. Alright, so I haven't made an actual scratch pass yet, so now we're going to come up and we got everything set on our zeros, and now I'll line up on this yellow dot over here on the threading dial. Here we go. Alright, once I get to my shoulder, I stop it, I disengage the half nuts, stop the lathe, back out, and I'm going to reverse it, reverse the spindle, and line that dot back up on the threading dial here. Now we'll come back in without feeding in. We're going to come back into our zero there, and let's check it. See that? Back out, reverse it, catch the threading dial on the same dot, and then come back into your zero. Now let's verify that we cut it right. We're wanting a 1.5 pitch. I gotta get it to where I can see it. Okay, that's correct. 1.5 pitch. It does make it nice with a machine with a foot pedal because you can stop everything a lot faster. Just a standard hex nut goes on the end of this. There's a piece or something, kind of plate that goes on there, and then a nut goes on it to tighten it up. Alright, looks like we got a pretty good fit right there. So all we need to do is just give it a light filing, remove the sharp edges on it, and that thing will be done. So there's just another quick little simple crash course on metric threading on a standard pitched lathe, you know, disengaging the half nuts. Just if you'll use this little trick, now this is just what works for me. I put a dot on that one and I use that same dot every time. So as long as you start on that dot and you return the thread dial on that dot without going around it either way, lining up on the same position every time, you'll always line that thread up when cutting a metric over here on a standard pitch lead screw.